We have a more general version of the Cauchy's integral formula. We make the same assumptions as before on the contour C and the point set 0, that this point should be interior to this simply connected and closed curve C with positive direction. And this denotes the nth derivative of f. This function at point set 0 has a function value which is equal to the faculty of n over 2 pi I multiplied with the following integral over c. We have the integrand f of z over z minus z0 to the power of n plus 1. And as before, multiplying with 2 pi I and dividing with n faculty, we obtain a formula which is more suitable for all tasks we are going to consider. So this formula is the formula we are going to apply. Recall that the faculty of n is equal to 1 times 2 times 3 up to n. And the faculty of 0 is 1. Let's consider an example which illustrates the use of the general formula. For example, in the case when n equal to 2, we let C be the circle given by this equation. The absolute value of z is equal to 1. And we assume, as before, counterclockwise direction. And we want to find this integral by using the general Cauchy's integral formula. So in this case, z0 is assumed to be equal to 0, because we see that making z0 equal to 0, we are able to reformulate this integral in terms of this f of z over some z minus z0, which in this case is 0, and n is in this case equal to 3, in fact. Sorry, I said 2, but it turns out to be 3, because then we have we get to the power of 4 in the denominator. Okay, so by using f of z equal to the exponential function of 2z, we obtain directly the Cauchy's formula, the expression of the Cauchy's formula. So in this case, we just go back and see what the Cauchy's formula says. It should be the nth derivative, so in this case the third derivative at point z0, which is 0, multiplied with 2 pi I over 3, the faculty of 3. So therefore we obtain this expression, and the nth derivative of the function, exponential function of 2z, is not very difficult to compute. Here we have the derivative of this function is 2 times the function itself. The second derivative is 4 times the function itself, and the third derivative is 8 times this function, exponential function of 2z. So if we now insert this z0 in this third derivative, we obtain, which is 0 here, we get 8 times the exponential function of 2 times 0, which is 8. So inserting this in the in this expression, we obtain the following value: 2 pi I over 3 faculty. 3 faculty is 1 times 2 times 3, which is 6. And we know that the exponential function of 2 times 0 is 1, so then we have the number. It turns out to be 8 pi I over 3.